Hello and welcome to part 3 of the PyAutoGui tutorial series, and in this one we're going to see how we can locate an image on a screen, how we can take a screenshot, as well as how we can check the pixel color values, whether they match with what we specify or maybe not. So first, how do we locate an image on screen? If you're wondering why I have the calculator on the right side, well, what I did was I took a snippet of the number 9 and saved it as an image, num_9, which, as you can see, it's a PNG file with dimensions 91 by 89, and we're going to see if we can locate it on our screen or not. So first, we're going to import PyAutoGui, and the function that we're going to use for this purpose is PyAutoGui.locate on screen. Now note that on and screen are with capital letters, and then in the brackets we're going to specify the name of our image, or in this case it's num_9.png, and I would like this to be printed, so I'm going to print this and let's see what the output would be. But note that Python is quite fast when it comes to executing, and if I run it with this IDE I would get the console out. So I want to import time and use time.sleep for 2 seconds. So at the moment of running I can still see the calculator, so I can minimize that, and now Python should be able to see the number 9 on my screen. And this is the output. So we get the position, which is the left border of our image, as well as the top. So if we take a look at this, the X and Y starting point of our image are at 1264 pixels X coordinate and Y coordinate of 595, and the width and height matches with the width and height of our image. Now if we want to click whatever image we have, we can use PyAutoGui.click, and then in the brackets we can specify again our image name. So I'm going to copy this part out because we don't want that to run, but we still want that 2 seconds to be there, and this is how it works. So it goes to our image once it's found, but if we have multiple appearance of the same image, then it goes to the first one and it clicks that one. If you want to find multiple images on screen, what I have here is I've used this number 9 and I've just made it as a photo but appearing 3 times. We can get the position of each of these appearances, and instead of using locate on screen, what we're going to use is locate all on screen. So it's quite similar, but printing it like this would not add value, and this is why. So if I print this out, what it creates is we won't see the output, we would see a generator object, and it doesn't add a lot of value. Instead, what we're going to do is we're going to store these so-called coordinates into this list, and then for every element in coordinates list we would like to print that element. And the output would be quite similar to what we had when we located on screen our first number 9 on the calculator, except now we have 3 different data points. So this is where our first number 9 starts, this is where our second one starts, and this is where our third one starts. The width and height remains the same for all, so that doesn't change. Now you can use this, for example, if you are playing a game where, I don't know, for example, you have falling objects that are exactly the same, then you can take a snippet of one of the objects, save it, and then use PyAutoGui to click those objects for you. Now keep in mind, if you have an object that, even though is similar, is actually same, it comes in different sizes, that is different. So it's comparing pixel by pixel, and what I would advise you to do is, if for example you have a falling blue square, then take a screenshot, but not of the entire square, but maybe of the middle of it. So if it comes in a smaller size, under the assumption that it's the exact same color, then it would still be identified and clicked by PyAutoGui. And that would be all regarding locating image on screen, or locating multiple images on screen. And the only thing that I would also use is if you're using some script that takes a lot of time, when you use PyAutoGui.locate on screen and then the image name, which in this case is num9.png, you can also set grayscale to be equal to true, which makes this function about 30% faster. And the default is red, green, blue, so this grayscale is set to false. So you just need to set it to true like this, and it would speed up a bit. Next, we're going to see how we can take a screenshot. Now, keep in mind that even though if you have, for example, multiple screens, PyAutoGui only takes your main screen into account. So even if you use the locate image on screen function, it would only search for that image on your main screen. But in order to take a screenshot, you would use PyAutoGui.screenshot. Now, the question is, what this function does is, yes, it does take a screenshot, but what then? Because right now we have this function running, but it's not saving a file in our folder. We don't also have a variable that stores that image. So what we need to do is, one, we can either create a variable, let's say our image or maybe sh screenshot to be equal to our PyAutoGui function, or we can use our brackets then to specify our file name. So let's say screenshot1.png, and if I'm going to run this, then in our folder we should find a screenshot1.png being created. So as you can see, the dimensions match the resolution of my main screen. Now if you want to take a screenshot not of your entire screen but maybe part of your screen, you can specify region to be equal, and then in additional brackets you're going to specify 4 points. The first two are the x and y coordinates of the starting, so the top left of your screenshot. So let's say it's 0, 0, and then I'm going to specify the width and height of the screenshot. So let's have it 600 by, let's say, 1000. And I'm going to run this, and let's see what we have in our folder. So our second screenshot would be different than our first one. Actually, I just saved it by the same name, but as you can see, our x, maybe we can just check the properties. So we have dimension 600 by 1000, which is what we specified here. And if we open it, we will see that it starts from the top left of our main screen, and then it takes all the other pixels that we've specified. So this is how you would take a screenshot based on a region which is not your entire screen. Again, it only takes your main screen into account. Now, if you want to check whether a color matches of a pixel, what we're going to do in order to demonstrate that is we're going to create a variable which would be equal to image, and our image would be equal to PyAutoGui.screenshot. So we would take a screenshot and store it as an image variable. And that image is now, well, what we see at the moment, that is our image. What I want to do is I want to check, I'm going to print, or well, in this case, if I'm using the console, then I don't even need to print, but image dot get pixel, and then in double braced, what I'm going to do is I'm going to specify the x and y coordinates of a pixel. So let's say I want to check the pixel with coordinates 200 by 600. What are the red, green, blue values that it has? And it's 255, 255, 255. Now, if I want to see where that pixel on the screen is, I can use PyAutoGui.move to 200 by 600, and then here it is. So it's a completely white point on my screen. Now what I can do is I can check whether PyAutoGui.pixel, this is again all lowercase, now I get matches color with a first uppercase letter. And then here what I want is, does this 200 coordinate X and 600 pixel coordinate Y matches with the following expected red, green, blue color? And as you can see, the default tolerance is 0. What it means is that it would return true only if it is exact match. So 255, 255, 255. And if I run this, then I get a true. So the return is true, which means the X coordinate 200 and Y 600 is matching this red, green, blue code. But what if I want to check, what if you are comparing with 250? Because yeah, let's check with a similar code which is not exact. Well, we would get a false. But this is where tolerance comes into play. So we can set tolerance to be equal to 10, which means if any of these values deviates by 10 or less, then it's still acceptable for us. And in that case, we get a true value returned. So this is something that you might use for checking multiple images. For the screenshot part, I've seen it used by Upwork, which is one of the probably the largest freelance platform at the moment. But when there's a contract between clients and freelancers on hourly rate, it takes screenshots of the freelancer randomly. So basically, it probably has something that is similar to it imports a random, which generates a random number, which is basically the countdown. And then once it counts down to 0, then it takes a screenshot and it saves it to its platform, which can be seen from the client's point of view as a proof of work. And then of course it generates another random number, which is probably, I don't know how often it takes screenshot, but I can imagine that it's like 5 or 10 minutes. So maybe it generates a random between those two time frames. And then it takes another screenshot and so on. That would be all regarding this tutorial, and I'll see you in the next one.